afternoon, good evening, depending what time you're watching this video. My name is Professor Kasha, this is Professor Watson. We're going to be doing some problems with factoring, which will appear on your final examination. So this is number 31 in your study guide, and as you can see, it has 4 terms, uv minus 6u plus 5v minus 30. So whenever you have 4 terms, that's a signal to draw the line in the middle. And when you draw the line in the middle, we're going to factor from each part separately. So I want to go look at the first 2 terms. In the first 2 terms, I see something in common, which is pretty obvious, which is a u. So I'm going to take out the u. And factoring really means division by the GCF. So I'm going to factor out the u. That means you're dividing each term by u. So the u here cancels, the u here cancels, and I am left with v minus 6. And Professor Watson will do the second part.
Now, first of all, let's copy down this sign. It'll either be a plus or a minus. I'm going to copy a plus sign, so I don't try to show multiplication, but keep it addition or subtraction. My common factor between 5v and 30 is 5. So, plus 5. I'm going to divide both of these by 5. And when I do, the first term divided by 5 leaves me with a v, minus, and the second term divided by 5 leaves me with a 6.
And this is the point at which you should be very happy, because you have the same factors. That means you did it correctly when you have the same factor showing up. That's one of your factors, v minus 6. And then the other factor is?
The other factor is going to be u plus 5. So I have a u, and then my plus 5 comes from over here.
Right, the u and the plus 5. That's how we got that factor. And you are done. And if you want to check your answer, just FOIL, and you will get the original problem back. So this is number 38. This is a trinomial. But this is a simple trinomial because the leading coefficient is just 1. There's nothing in front of the t squared or x squared or p squared. So when you have a trinomial like this, it's relatively easy to factor. You can just go ahead and jump to the 2 parentheses immediately, and you can see that t squared is just going to be t and t. So that part is the easy part, but then we have to find factors of the last term that makes the middle term. And to do that, we have to watch our signs. And the last term is positive. That means we have to add, and the signs will be the same. However, if it's negative, you will have to subtract, and the signs will be different. So when I say the same signs, that means they'll be either plus plus or minus minus. But when they're different, 1 plus, 1 minus, make sure you write this down. If you're not writing this down, you have to rewind. Okay? So factors, because 48 is positive, I'm going to find factors of 48 that add up to make 14. Factors of 48 that makes 14 is 8 and 6. So I'm going to put 8 here and 6. Professor Watson, what am I missing?
You're missing your signs, Professor Kasha.
So how am I going to do my signs?
Well, I need to add and get a negative 14. So that means that I need 2 negatives.
2 negatives. So therefore, for the 2 negatives, and we're done. If you thought it was t plus 8 times t plus 6, understand that plus 8 plus 6 makes a plus 14t, and the middle is a negative. So once again, double check your work, okay? So the signs had to be the same, and we match it to what the middle is. So in this case, negative and negative. That's number 38.
This is number 12 from your review packet. This is slightly different than the last problem because this one is not an expression, this one is an equation. I know it's an equation because I have an equal sign. Now I'm going to factor this side still, and I'm still going to use those sign rules that Professor Kasha demonstrated for us just now, but then I'm going to have one extra step. So first of all, since I have a coefficient of 1 for this quadratic term, I know that I can set up 2 binomials. I have n and n. Let's not forget to equal 0 because this is an equation, not just an expression. Now this is a negative. This is a minus right here, so I need to identify what that means when I'm looking at signs. What does that mean for our signs, Professor Kasha?
Well, because the last term is negative, that means that the signs will be different. And we are going to subtract the factors to make the middle. So in this case, we're going to look at 28, and we're going to find the factors that subtract to make 3. Do not add, we're subtracting. So what factors of 28 that we subtract to make 3?
Well, we know that 14 and 2 are factors, but if I subtract those, if I say 14 minus 2,
that's 12.
That's 12, so that's not going to work.
Yeah, we don't like that.
So instead, we're going to pick 7 and 4. If I subtract these, what do I get?
You get 3.
I get 3. Now, what I really need, I see 3 here, but I don't really want a 3. What kind of 3 do I want?
We want it to be a negative 3.
Okay.
So when the signs are different, okay, you want the bigger number to match the sign in the middle. Okay, so 7 is bigger than 4, so 7 will be negative, 4 will be positive. So it'll be n minus 4, n minus 7,
Minus 7.
and then n plus 4.
All right, are we done yet?
Well, if this was a factoring problem and there was no equal 0, then I would be done. But because you have an equal 0, you're solving, and it's going to also say solve, not factor, which means you have to go further, which means you set each factor equal to 0. And Professor Watson will show you that.
So if I multiply two things together, even if they're binomials, and I get a 0 for an answer, that means either the first was 0, the first factor was 0, or the second was 0. And I'm going to explore both options. Now, if n minus 7 equals 0, how do I solve for n, Professor Kasha?
Well, you do the opposite to both sides. So opposite of subtracting 7 is to add 7 to both sides. So we have n equals 7 for the first part. And then here we subtract 4 from both sides, and we get n equals negative 4. Now you might be able to do this in your head, but we strongly advise you to do it on paper because a common mistake that people make are with their signs. So if you just go too fast, you might say the solution is negative 7 and positive 4. So make sure you do your work on paper to make sure you don't make any careless mistakes.
In my math lab, then you'll be answering with a comma. So instead of typing n equals 7, n equals negative 4, then they will provide a field for you to fill in. And so you'll say 7 and negative 4. You could also say negative 4, comma 7, as long as your signs are with the right numbers.
And that's number 12. This is number 23 in your packet. This is their factoring, but this is a difference of squares. How do I know this is a difference of squares? Well, difference means subtract, so I see the minus sign there. 16 is a perfect square, so it's s squared, so it's r squared. So this one is one of the easier types of factoring. Go and make it 2 parentheses. Because there's a minus in the middle, the signs will be different. So that means you're going to have 1 plus, 1 minus, and r squared is going to be just r. And 16, what's the square root of 16? Is 4 and 4, because the square root of 16 is 4. And then s squared is just going to be s and s. I have r plus 4s and r minus 4s. I'm done. Type this into my math lab and move on with your life. That's number 23.
In number 72, we're going to factor a trinomial where the coefficient of your quadratic term is no longer a 1. So we need to employ a couple of new methods. Now we're going to use 2 different methods. Professor Kasha is going to use the AC method, and then I'm going to do the same problem with the box method.
And we advise that whichever method you have learned in class, go ahead and stick with the method that you're most comfortable with. But I'm going to go ahead and show you the A times C method. It's called the A times C method because the number in front of your B squared is the A, and the number by itself is called the C. And the first step you do is multiply the A and the C. So I'm going to do negative 15 times 3, which gives me negative 45. And please write your sign down because that's very important. Just like factoring the simple trinomials, if it's negative, that tells me that I'm going to subtract and my signs are going to be different. So I have to find factors of 45 that subtract to make 4 in the middle. So knowing your multiplication factor will help you here. 45 is a pretty obvious number where I think it's 9 and 5. That's probably my first guess. And I'm lucky because 9 take away 5 is 4, which match my middle. But now I want to make it a -4. So because the signs are going to be different, the bigger number will match the sign. So the 9 will be negative, the 5 will be positive, and you can check. -9 plus 5 is -4. And in case you made a mistake and you thought it was +9 minus 5, you would see that this is a +4, and you would see that that's wrong, not to use that. So once you do that, the first term stays exactly the same. The last term stays exactly the same, and I'm replacing the middle with my two factors here, minus 9b plus 5b. This is 4 terms, which means I can go back to factoring by grouping. So you draw a line in the middle, and this is factoring by grouping. What's in common with 3b squared minus 9b is a 3 and a v. So divide both terms by 3 in the v, divide by 3 in the v. The 3 here cancels. V squared over v, you subtract the exponent, so there's 2 take away 1, that's just v. Minus 9 over 3 is just 3, the v cancels. Go to my second group, okay, and to factor the second part, whatever the sign is here, just copy it and write plus sign, so that you do not mistake this for multiplication. So what's in common here is a 5. I cannot factor out a v because both terms must have a v. See, in the first part, both of them have a v, so I can take out the v. Second part, they don't all have a v. So I divide by 5, this cancels, so I'm v minus 15 over 5 is 3, and this is the part where I'm very happy because both of my factors here are the same. That means I'm done. So my first factor is v minus 3, and my second factor is 3v plus 5. And I'm done. That's the A times C method. You can FOIL to check your answer. You would get this trinomial back. Another method, as Professor Watson said earlier, is the box method, which he will show you.
So I'm going to factor with this box method, and that is drawing a graphical organizer to help me out with my factoring. Now, the box method is the same method as trial and check. It just has something to organize it a little bit. So I'm going to choose to put my first term in this column and my last term in this column. And I'm putting the sign here because I want to make sure that I remember that I have 2 different signs to work with. And then what I'm going to try to do is get a -4v when I set up my factors and get my diagonals. So now I look for factors of 3v squared. 3v and v are the only options that I have. Now take a look at this 15. My factors of 15 are 3 and 5. Now I know that I'm not going to choose to put a 3 here. This is obviously wrong, and the reason why this is going to be wrong is take a look at the original trinomial. Do you have a greatest common factor? You don't have a greatest common factor of 3, which means that none of my rows should also have a greatest common factor. If I put a 3 in this spot, that means that I should be able to take out a 3 from this binomial, meaning that I should have been able to take it out earlier. I know that the 3 can't go in that spot. So I have a 3, but I can't put it next to that 3. I'm going to have to put it over here and move it away a little bit. And then the other option is I can put a 5 right there. So now I'm going to check my diagonals. If I look at the diagonal here, I get 9v. And if I take a look at the diagonal here, I get 5v. And I can get a 4v out of this. I just need to be crafty about how I choose my signs. If I want a -4, that means that the 9 must be negative, so then this right here must be the negative, which leaves this 5b to be the positive, and I'm going to put the positive right there with that 5. Now my factors are going to be my rows. So when I read back to get my rows, I'm going to choose 3v plus 5, and the other factor is v minus 3. Now Professor Kasha, my factors were in a different order than yours.
Ooh. Is that okay? Well, what does it mean for 2 binomials to be next to each other? It means that this is multiplication. Well, 3 times 4 is the same as 4 times 3, so order does not matter with multiplication because of the commutative property. 3 times 4 is 12, 4 times 3 is 12. When you FOIL this way, or you FOIL it the other way, it's exactly the same answer. The way you type it in does not matter as long as you have v minus 3 and 3v plus 5.
This is number 4 in your review packet. Now, Professor Kasha, do we have an equation or an expression?
This is an equation, and the reason why we know that, it has number one an equal sign, so that tells me it's an equation, not an expression, and most likely it's not going to say factor, it's going to say solve.
So I need to factor, and I have a few options. I could choose the AC method.
Yes, ma'am.
See the previous video for that. And then I could choose the box method, or sometimes called the necklace method, or trial and check. So my factors, I'm going to choose 3x and x, and I'm going to choose 2 here and 1 here. 3x times x makes my 3x squared, and then 1 times 2 makes that 2 right there. I need to choose some signs. Now I need a negative 5 in the middle. That means I want a negative 6. The negative 6 comes from here, and a positive 1x for these two. Professor Kasha, could you check my factors?
Yes, I can. First, we'll get to equal 0. First thing, the signs are different because of this last number here, so we know it's going to be different. And we're going to quickly check to make sure it's correct by checking the middle, because as Professor Watson said, 3x times x is 3x squared. 1 times negative 2 is minus 2 here, so we know these two terms are good. So I'm going to use a necklace as a check. So you do 1 times x here, that's plus 1x. And then you have 3x times negative 2, that's minus 6x. So you multiply the inner and then the outer, the oid and foil. Okay, so the oid and foil, because that's what makes the middle. And 1x minus 6x checks out to be negative 5x. So we're good to go, Professor Watson.
The next thing is I need to set each individual factor equal to 0. So I'm going to choose the factor 3x plus 1 equals 0. And the other factor is x minus 2 equals 0. I'm going to solve by subtracting 1 from each side. So 3x, this cancels, is equal to negative 1. I divide both sides by 3. And x is equal to negative 1/3 for the first factor. The other one, since I'm subtracting 2, I'm going to add 2 to both sides. And then x is equal to 2. In my math lab, they give you a field. They'll often say solve and separate your answers with a comma. This will be the blue instructions underneath the problem. So your answers are negative 1/3, comma 2.
And please don't forget your comma.
This is number 2 from your review packet. I'm evaluating this expression. Now it's an expression because there's no equal sign. I'm not solving, I'm plugging in numbers. Now when I plug in these numbers to these variables, I need to put parentheses around the new number each time. So for x, I'm going to keep my parentheses and square, and the square goes on the outside of those parentheses. That would be a negative 4. It's important that I have the parentheses there to identify that when I square a negative 4, I get a positive 16 instead of just squaring the 4 and then getting a negative 16.
You may want to, in the beginning, if you have x equals an a, just put parentheses around it, and z equals an a, just put parentheses around it so that you know when you plug it in with the parentheses.
Same thing with y. I'm going to put parentheses around here even though it's of no consequence because the 5 squared is still going to be 5 squared. Then I'm going to divide by, and then y squared. So I have a 5, and then it's squared, and plus z squared. Now I'm going to put my negative 5 in right there. So negative 4 in parentheses squared is positive 16, and then 5 squared minus 25 over 5 squared, 25, and then plus, and this is negative 5 squared. Now that square is going to cancel out the negative, so I end up with plus 25. So I'm not saying positive times negative because according to order of operations, I have to do my exponents first. So I'm going to square this negative 5 before I get to add it. So this is negative 9 over 50. And I know that this fraction doesn't reduce because 9 is made up of a product of 3's. And then 50 doesn't have any 3's in it. It has some 2's and some 5's, but really no 3's. So I know that there's not going to be a common factor for me to cancel.
And once again, make a note that here the minus sign is outside the parentheses. So whenever you have a minus sign outside the parentheses, it just stays minus. So that's why this is minus 25. Do not change this to a plus.
Here's an equation with fractions. And fractions are not scary, right?
That's right.
Not scary. So what we're going to do, since we have an equation, it's not an expression, but we have an equation, which means we have two sides. we're going to clear our fractions. And so in order to clear the fractions, I'm not going to have fractions after this step, but I need to identify what the least common denominator would have been should I care. So what is the least common denominator of 3 and 9, and technically 1? What's the LCD, Professor Kasha?
It's going to be 9 because 3 goes into 9.
Right. Now, what I'm going to do with that 9 is I'm going to multiply every term by 9. Now, I want to multiply this term by 9 and this term by 9, but don't forget, just because this one doesn't look like a fraction, it still is a fraction because it's still a fraction over 1, and it's still a term, and you want to be fair to your terms. So every individual thing, I have 1, 2, 3 terms. Each one gets to be multiplied by 9. So I'm going to cancel that 9 and that 3, and I have a 3 left over. Nothing cancels here, and this 9 and 9 cancel, and I'm left with a 1. You should not have any more fractions at this point because our goal was to clear the fractions, and if you have any fractions left, that means you didn't pick the right LCD. So let's multiply what we have left over. We have 6x minus 1 times 9 is 9 is equal to 1 times 7 times x is 7x. I need to combine like terms. Now, I have an x term on the left, I have an x term on the right. I want to combine like terms but over an equal sign, which means I'm going to have to change signs because I'm going past an equal sign to combine. So minus 6x minus 6x. These cancel. I have negative 9 is equal to 1x. So my answer would be x is equal to negative 9.
Okay, so we're going to also have some formulas or literal equations. So this is number 74. We have G equals W plus WRT. It's very important to read the instructions. It says solve for T. Okay? It makes a big difference which variable I tell you to solve for, because the steps I take will be different if I told you to solve for R or to solve for W, so on and so forth. So I want to solve for T. So I want to eventually get T alone. So I'm going to circle the WRT, knowing that T is what I want to get alone. Okay? So the way I think about this, as this is an analogy that would help you, is I think about T being married to both the W and the R. Okay? That's illegal. And then the W is a tag-along friend. Okay? So which one is easier to get rid of? Your spouse or your tag-along friend? The tag-along friend you just get rid of, just say I'll see you later. So I take away W from both sides, because the opposite of plus W is subtraction. So this cancels out. And then I have G minus W equals WRT. Well, obviously it's illegal to have 2 wives or 2 husbands, so therefore T is going to be in trouble. They're both are going to want to leave the T. Okay, so we're going to do a legal separation by putting in the multiplication dot, and we're going to do a divorce. Okay, I'm going to divide both sides by W and the R, and both sides by W and the R at the same time. Both of them are leaving the T. So now you have T equals G minus W over WR. T, as you can see, is single. And when you get T single, we're done. And you move on with your life. Okay? Okay, this is number 64. You're going to have to solve an inequality. Okay? When you do it in my math lab, whether it's multiple choice or not, they're going to want the variable on the left side. Especially when you do set notation, the variable must be on the left side. So even though it technically speaking doesn't matter which side you move the variable to, I'm going to always, with inequalities, move it to the left side because I think it's safer for me. So this is a negative 1u. So I'm going to minus 1u from both sides because I want to remove it from the right side. So we have 8 minus 2u is more than 12. Okay? So once again, we're going to solve this equation. Okay? And if it helps you, you can rewrite this as negative 2u plus 8 is more than 12. Okay? And hopefully you're okay solving and getting u alone. But if you're not, I think about the 2 and the u being a married couple. I think about the 8 as being a tag-along friend. Which one is easier to get rid of? It's easier to get rid of your tag-along friend, and then you have to divorce your spouse. Okay? Do not tell my wife this. Okay? So take away 8 on both sides. Okay? So we have negative 2u is more than 12 minus 8 is 4. And to get u alone, we have to do the divorce. So the opposite of multiplication is division. I'm going to divide both sides by -2. When you divide both sides by a negative, the inequality sign will flip over. Okay? But only when you multiply or divide by a negative. If I was dividing by a +2, the sign would have stayed the same. So I have u is less than +4 over a -2 is a -2. And most likely, they're going to make it in set notation like this. And as I said earlier, the variable must be on the left-hand side. And this is the solution set. Okay, so we just solved this inequality. So we have u is less than -2. So my next step is to graph my solution on a number line and to express it using interval notation. So here, u is less than -2. You always look at the variable, not the number. So because u is less than, that means I shade on the left-hand side. Some people will use a shortcut that only works when the variable is on the left-hand side. We have an inequality sign. You can actually make it like an arrow by drawing in a dotted line. It's pointing to the left side. It's a nice, neat trick, but it only works if the variable is on the left-hand side. So we shade all the way over. And because it's less than but not equal to, I use parentheses. If it was less than or equal to, I would have used a bracket. Okay, so I'm using a parentheses in this case because it's just less than. Okay, and I shade to the left because u is less than -2. Once again, you're looking at the u, not the -2. So don't say -2 is more, u is less, that's what we go with. So this is my graph. The interval notation, you always look from left to right. So you're going to write negative infinity first. All right, and then negative infinity is always a parentheses, comma, -2 parentheses. Okay?
Number 29 from your practice packet. Now I have 3 x's. Everything has the same base x, and so I'm going to follow my order of operations. The order of operations, first of all, tells me that I need to simplify these exponents right here. I have an x to the -5th, and it's raised to the 4th power when I'm talking about exponents, and this is where I need to start. So these count as multiplication, so I'm not worried about the 3 and the 2 just yet. So the very first thing that I need to do is I need to multiply here. Now with my exponent rules follow the pattern of order of operations, but they're one thing easier every time. So when I'm looking at exponents, then the way they work is multiplication. In a minute, when I multiply these two, I'm going to add whatever kind of thing I'm doing to my bases, x's, then I'm going to do one thing easier with my exponents, and that's the way that they work. So right here, I see exponents. I'm going to raise it to the 4th power, and the behavior that it's going to exhibit is that I'm going to multiply those two things together. So I have x to the -20. And then I'm going to keep my x cubed, x squared. The next thing I need to do is multiply, and the multiplication's right here. Again, multiplication, the one step easier than that is addition. So this is going to look like addition of my exponents. That's the way that I multiply. So x to the -20 over x to the 5th power. Now, I have multiplication and or division. They're going to work at the same time. And this fraction bar tells me that I'm looking at division. So since I'm looking at division, I need to identify which one's the bigger number, +5 or -20. Now my bigger exponent is on the bottom. 5, a positive, is going to be bigger than -20 because 20 is negative. So what I'm going to do is I'm going to say that this negative one, or this small one, has to move and change signs. If you always say that the small one has to move and change signs, you'll end up with your positive exponents. Your instructions tell you that you need positive exponents in your answers. So what I'm going to do is I'm going to keep my x to the 5th, and then this 20 has to move down here, and it has to change signs. As it moves, it changes signs. Now I need something to go in this numerator here. I'm going to put a 1 right there as a placeholder. Professor Kasha, would you like to show where that 1 came from?
There's always an invisible 1 in front of all your variables. So if this disappears, then the 1 is going to be visible. So make sure you make that 1 visible.
So when things move to the denominator, you still need a 1 as a placeholder. If everything moves to the numerator, then the 1 in the denominator is assumed.
Correct. Just to clarify, 1/3 has to stay 1/3. But if it's 3 over 1, then you can just go ahead and make that 3. But a lot of people get mixed up and will say 1/3 is equal to 3 and just drop that 1, and that's incorrect because there's a big difference between giving me 3 donuts versus giving me just a third of a donut. If you give me just a third of a donut, I would be grouchy. But you give me 3 donuts, I would be a much happier person with the sprinkles on top. Sprinkles on top.
Lesson learned. Feed Professor Kasha.
Yes.
Now, I had a 1 in that numerator as a placeholder. It was the coefficient of that x to the negative 20. And when that x to the negative 20 moved to the denominator, and I got an x to the positive 20, then I still had that 1 as a placeholder. It's not a 0 because when you divide everything out, you end up with a 1. If you divide everything, then you get a 1. If you subtract everything, you get a 0. Please don't confuse those two. So the next thing is that I have that 1 as a placeholder, and then I'm going to add the 5 plus 20. That's x to the 25. Again, we chose to take the smaller exponent and move it to where the larger exponent was, so the small one has to move and change signs, and that's how I'm going to end up with a positive exponent every time.
And there's one other way you could do this, and it depends on how you learned it. You have x to the negative 20 over x to the 5th. You learn that you subtract, and if you subtract, then you have negative 20 minus 5. Where does the minus sign come from? From the operation that we're doing, which is subtract. But we're not going to actually subtract because the signs are the same. So when you have like signs, you add and keep the sign. So negative 20 and negative 5 is negative 25. So don't think that we're literally always subtracting. We're setting it up as a subtraction problem, but you have to follow the rules of your signs. Okay, so this actually becomes x to the negative 25, but you'll learn you can't keep negative exponents, so this becomes 1 over x to the positive 25, and you get the same answer. Okay, this is number 67. So we have 12a to the 8th, g to the 9th, minus 8a to the 6th, g to the 7th, over 4a to the 4th g. Now, it looks overwhelming. It looks difficult. Whenever you have a polynomial on top divided by a monomial, just one term, I like to say divide and conquer. What do I mean by that? Write this problem as separate pieces. So you're going to write this as 12a to the 8th, g to the 9th, over what's on the bottom, which is 4a to the 4th g, minus 8a to the 6th, g to the 7th, over 4a to the 4th g. And with the numbers, we're going to actually divide. But remember, when you're dividing with variables, we actually subtract the exponents. Okay? So I'm going to go ahead and do it. So 4 into 12 when you divide is 3. For the a's, 8 take away 4 is a to the 4th. And this g has that invisible 1. So make that 1 visible and subtract. 9 take away 1 is g to the 8th. Minus 4 into 8 is going to be 2. So the numbers you actually divide as normal. But for the variables, we subtract. So for the a's, 6 take away 4 is a to the 2nd power. And for the g, remember that 1. Don't forget that 1. 7 take away 1 is g to the 6. And this would be it. You cannot go any further than this. They're not like terms. How do I know they're not like terms? This is a to the 4th. This is a squared. They're not exactly the same. This is g to the 8th. This is g to the 6th. Not exactly the same. It might look similar, all right, but there's a big difference between peanut M&Ms and plain M&Ms. You can't mix the two. Because if you do, you will be confused about what you're eating. So keep your peanut M&Ms separate from your plain M&Ms.
Professor Kasha, am I allowed to do this if I don't have a monomial as a denominator?
No.
No.
You're not. But on the test, you only have a monomial on the bottom. You're not going to have a binomial or anything like that for the test. If you have a binomial in the denominator and a trinomial in the numerator, then that's going to involve factoring and canceling. So make sure you study that topic.
So this is number 63 from the review packet. Gwen earns $580 per week and has 24% of this amount withheld for taxes, Social Security, and Medicare. Find the amount withheld. So what we're looking for is we want to find 24% of $580. Now, a couple things I'm going to need to change. First of all, I don't want to use a percentage symbol. I want to use a decimal instead, so I'm going to choose 0.024. The of is a times sign, and then I'm going to keep the 580. Mr. Kasha, would you like to do the honors of multiplying?
Sure. So you have to do some tedious multiplication because you're not allowed to use a calculator on this exam.
That's what I made you do it.
So we're going to multiply. I'm going to just for a moment ignore the decimal point. You do 4 times 0 is 0. 4 times 8 is 32. Carry the 3. 5 times 4 is 20, plus 3 is 23. And then before I multiply by the 2, I got to put the 0 in as the placeholder. Yay, this is fun. All right, 2 times 0 is 0. 2 times 8 is 16, carry the 1. And 5 times 2 is 10. 10 plus 1 is 11. Add 0 plus 0 is 0. This is a 2. This is a 9. This is a 3. This is a 1. But don't forget that this actually means 0.24. How many digits is after the decimal point? 2. So you go 2 places back. So it's $139.20. Yay.
Very good, Professor Kasha.
And that was fun.
That
you
was
guys
really
get to have the same amount of fun on your final examination because you're not allowed to use a calculator.
Now, on your final exam, then they have a field for you to fill in. You don't have to worry about the units because they give you the dollar symbol and then the field. So we're looking at $139.20. This is number 68 from the study guide. A ball player made 563 field goals of 902 attempts. What percent of his field goal attempts did he make? So we're looking for a percentage. First of all, we need to set up a fraction. So the ones that he was successful, success over attempted, that would be his 563 over 902. The fractions aren't scary, are they, Professor Kasha?
They can be.
They can be, but they're not. And in fact, what are we going to do with this fraction?
Well, we're just going to divide, change it to a decimal, and make it into a percent. That's it. The top number represents your part, right? And the bottom is your total. And the question asked me, what is the percent? So we have to change a fraction to a percent. So we're going to do long, tedious division. Of course, I'm going to use my calculator for this. What? No calculator?
There are no calculators on this exam.
Okay. There's no calculator allowed, so I have to do this the long way. Does 902 go to 563? The answer is no. So I'm going to add a 0.00. You can add 2 or 3 or 4 zeros. I always start off with 2, and then I add zeros as needed. Line up your decimal point, and have fun. So I'm going to estimate that 902 goes into 5,630. I'm going to estimate roughly 6 times. Okay. The reason why I estimate 6 times is because I'm thinking about 90 times 6 is 540. So I'm going to take an educated guess that it has to be 6. So you multiply. So 6 times 2, that is 12. Carry the 1. 6 times 0 is 0 plus 1. 12. 6 times 9 is 54. We're going to subtract. Okay. I can't take 2 from 0. Borrow. Yay. 10 take away 2 is 8. 2 take away 1 is 1. 6 take away 4 is 2. 5 take away 5 is nothing. And then you have to now bring down the next 0, and you're going to repeat the process forever. 902 into 2,180. I'm going to estimate about 2 times because I'm thinking in my head 90 times 2 is 180, so that's a little bit less than 200. So I'm going to say 2 times. So go ahead and multiply. 2 times 902 is 1804. My 2 times 2 is 4. 2 times 0 is 0. 2 times 9 is 18. I should probably cross that out so I don't confuse myself. We subtract. I hope I'm going to be done soon. I'm going to subtract 4 from 0. Can I do that? Borrow. 10 take away 4 is 6. 7 take away 0 is 7. And then borrow. This is a 1. 11 take away 8 is 3. Well, obviously I have a remainder, so I have to keep going. The problem says that I have to round to the nearest tenth after I convert this to a percent. So if I was to convert this to a percent now, it would be a whole number. So I have to move the decimal point over 2 places. So I have to go a couple more times. Okay.
You need to fill in 1, 2 more spots.
2 more spots. So that means I'm going to add 2. I'm going to add 2 more zeros, and we're going to go ahead and drop the 0. Okay, and let's just keep going. Yeah, 902 into 3,760 is going to go.
Ooh.
Oh, what?
4.
Good. Thank you for helping me. I appreciate that. So 4 times 902, I'm going to run out of room, is 3,608. We're going to subtract that. All right, what do we get? Just do it. You get 2, this is 5, this is 1, 52, and I'm squeezing. I have to drop that 0. I'm out of space.
Professor Kasha, from this last spot right here, I really don't need this number. I only need to find out if it's 5 or bigger or if it's less than 5.
Correct.
Because the only reason I need that is to see if I need to take that 4 and round it up or just leave it alone and leave it as a 4. Now, you already multiplied 4 times 902, and you got the 3,608. Now, what I have left is going to be less than that. So I know that this number, even though I don't really care about what it is so much, I mean, we can kind of see that it's going to be less than 2. I'm going to need a 1 in that next spot. So really the only thing is that it is a 1, but I'm mainly concerned that it is a number that is smaller than 5, because I need to round to this point right here. So I need to know if this number is going to stay a 4 or if it's going to become a 5. 1 is small, so I'm going to keep that a 4.
So this is so our decimal here is 0.6241, and to change it to a percent, we move the decimal point over 2 places to the right, and you will see 62.4%. So make sure you round correctly, and you write 62.4%. So even though they asked me to round to the nearest tenth, we had to at least look at the digit next to the 4 to make sure it was on 5 or higher, else we would have rounded up to 62.5%.
So if I had something here that was, instead of 1520, if I had something that was bigger than 4,500, then I know that I would be looking for something that was 5 or larger, which means I'm going to be rounding up.
And that's because 900 times 5 is 4,500. So knowing your multiplication facts does help here.
So we're talking about multiplication facts. We're also using a lot of estimation,
yes,
so that the numbers are not terrifying to us.
Absolutely.
This is number 39 from the review packet. Now this whole section is about word problems, and this one's not a word problem per se, but we do have proportion word problems. So I wanted to start off with a proportion, even though we don't technically have a word problem here. Now there are 2 methods. One of them is the way that we would teach you how to do it in class. Another one is a way that we would show you a special trick to get there faster. I'm going to show you the longer version first, and then Professor Kasha is going to show you the other way. So what we're going to do is we're going to multiply. I'm going to multiply this 56 times negative 11. So when I multiply, and by the way, there is a special trick to multiplying by 11. When I multiply these 2 things together, then I get a 56 and a 56. So I'll have a 6, an 11, carry, and I get a 6 right there. Now the special trick here is that you get to keep the 5 and the 6 and then add them together in the middle. That always works with the 11s. Now because I was multiplying a negative 11, I'm going to get negative 616, and that's equal to 8n, because I multiplied this times this. So notice a couple of things here. This equal sign stayed in the middle of them. It does not make one fraction. It starts with an equation and ends with an equation. Sometimes students ask, when do I multiply across and when do I multiply diagonally? And the answer is when I have an equal sign. That's an equation, and that's telling me that I need to cross multiply. I'm not multiplying the tops together. That would be an expression. So now I have a variable with a coefficient 8. I'm going to divide both sides by that. So 8 goes into 616. Now this was a negative 616, so I'm going to put a negative there to remind myself that I need a negative there. Now 8 goes into 64 8 times, but this isn't quite big enough, so I'm going to say that that's 7 times. So 7 times 8 is 56. I'm going to subtract. And when I do, I'm going to get 56. 8 goes into 56 7 times. Then I get 56, and I subtract, and I get a 0. So I would say that n is equal to negative 77. Don't forget the negative. Now, Professor Kasha, you show the alternate method.
Okay. Now, this first method works all the time, and of course you should know how to do it this way, but sometimes there's a shortcut. It does not happen all the time, but the shortcut is if you take a look at this fraction, 8 over 56 can be simplified or reduced. So I'm going to make my number smaller because I have learned in the last video that you're not allowed to use a calculator for this exam. So therefore, if I can make my number smaller, I will go ahead and do so. So divide by 8 because 8 goes into 8 and 56. So 8 divided by 8 is 1. 56 divided by 8 is 7. And then what I can do instead is write down negative 11 over n equals, not this, but 1 over 7. So it makes my cross multiplication easier to keep the equal sign in the middle. n times 1 is 1n, which is just n. 7 times negative 11 is negative 77. And there you go. You have the same answer. It works. A little bit shorter. The shortcut is awesome, but it only works if you can simplify the fraction on the right or the fraction on the left. But do not cross cancel or cross simplify. So if you think you're going to make that mistake, stick with the long way because you want to get it correct. Okay, so be careful if you use this shortcut, but I think it is cool. Thank you.
Next problem is number 73. These are proportions. Now we're going to set them up, but there are really 8 ways to set them up correctly, and I'm going to explore 2 of them. So number 73, Jim drove 78 miles in 2 hours. If he can keep the same pace, how long will it take him to drive 1,014 miles? Now, there are a couple of ways we could set it up. First of all, I need to just make sure that I'm consistent. So in the first scenario, what if I choose the miles per hour? So the miles he drove in the first scenario over the hours he drove in the first scenario. Now, I've done something that's different and something that's the same. The thing that's the same is that I'm pulling things from the first scenario. So they gave me 2 scenarios where, first of all, he's driving 78 miles in 2 hours, and they're going to give me another scenario later where I have a variable. So this is all in the first scenario. That's the part that's the same. There's something else that's different, and that's the miles and the hours. So if I want to make a correct proportion, then all I have to do is make sure that I'm consistent with my fractions. So if I choose the first miles over the first hours, I'm going to choose the second miles over the second hours. Another correct way to set this up would be to choose, what if I start with the hours from the first scenario over the hours in the second scenario, and that would be equal to, well, if I choose 1 over 2, then I'm going to choose the miles in the first scenario, and then the miles in the second scenario. So we're going to plug all this information in.
And I'd like to go ahead and say something. As you have to, once again, Professor Watson said this, be consistent. So if you do miles over hours on the left, you must do miles over hours on the right if you go down vertically. If you go across horizontally, you do hours to miles going across, and the bottom should be hours to miles going across. Just make sure you're consistent in however you set it up. So you can go either up or down, or you can go horizontally. Okay, but the key to setting up a proportion is be consistent.
So we're going to fill in both of these. So Jim drove 78 miles. So we're talking about the first scenario. So 78 is where miles in the first scenario goes over here, or this one has 78. So Jim drove 78 miles in 2 hours. So 2 hours would be the number of hours in my first scenario. That would be 2 right here. Now, also in my first scenario, I would have a 2 right here. And then the next part is, if he can keep the same pace, how long will it take him to drive 1,014 miles? That would be the miles in the second scenario. Over here, miles 2 be over here. And then what we're trying to find, or our x value, is going to be how long, or what's the hours in scenario 2. So I'm going to put my x here as my variable. Now, both of these are correct, and they both work, and the reason why is because in proportions, the next thing I need to do is cross-multiply. So if I cross-multiply this one, then I have 78x is equal to, and then I cross-multiply these two. This would be 2,028. Now, I'm about to finish this one, but first let me go over here and multiply. Over here, I have 2,028 is equal to 78x. So, these are the same equation, and I just needed to make sure that my original proportion was set up with some consistency, and then I'm going to get some version of the correct equation. And it'll all come out the right way as soon as I cross-multiply. Notice how in both scenarios my x was diagonal from my 78 because the right things had to be in place to cross-multiply. So what's next, Professor Kasha?
Well, solve for x by dividing both sides by 78.
Okay.
So I'll go ahead and do this side. And notice this is a fraction, and I recommend before you do long division that you can reduce the fraction if you want, or you can just divide 78 into 2028.
Now this right here is really close to 80. So I'm going to estimate 80 and say how many times approximately would 80, using these first two, go into 200. So how many times would 8
2.
go into 20? That'd be 2 times. So I'm going to estimate 2. And then when I multiply, there's a 6. 16, carry a 1. 15, 156. Then we'll make this a 19. And then this is a 12, 6, 4 left over. And then 4 is 68. So the next thing I want to do is I want to estimate how many times would 80 go into 468. How many times are we thinking?
I'm thinking 6.
Thinking 6 times?
I'm thinking 6 times.
So 6 goes in there. Or sorry, 6 times 8 is 48. Carry a 4. And then 6 times 7 is 42. Plus 4 is 46. Professor Kasha, you must be a math teacher.
I must be.
And so the answer is 26.
And when you do long multiplication and long division, once again, it's tedious, but be patient with it. Be very patient with it because you don't want to make a mistake here when you made it this far in the problem. All right, this is number 26, and this problem is a picture of a triangle, and they asked me to find the perimeter. To be more specific, this is an isosceles triangle because 2 sides are equal. But you don't have to know that terminology, but it's fun. So to find the perimeter, just add all the sides. Do 7 feet plus 7 feet plus 9 feet. Add it correctly, you would get 23 feet. And that is it. Just to clarify though, just in case you get mixed up, the perimeter, when you find the perimeter of a shape, it's just going to be the unit. So in this case, it was just feet. But if it was area, it would be feet squared. And if they asked you for volume, it would just be cubic feet or feet cubed. So in this case, it was perimeter, so it's just feet. Do not make it, because you see 3 feet, don't make it cubic feet. All right, so this is number 17. The problem says how much will it cost to carpet a rectangular room measuring 9 meters by 23 meters if the carpeting costs $28.25 per square meter. So the first thing I did was I drew myself a diagram of a rectangle. Okay, so it says per square meter, which means they want me to find area. Besides, the carpet does not go around; the carpet goes inside. Anything that goes inside is area. So I'm going to first start by finding the area of this rectangle. And that's very easy, just do length times width. So 23 times 9, 3 times 9 is 27, carry my 2. 9 times 2 is 18 plus 2, that's 20, so it's 207 square meters. That's the area of the room. However, I have to find the cost, okay? So doing long multiplication, I have to multiply the area by the cost per square meter. So I'm going to take this and multiply by $28.25. And you have to do long multiplication. And if you do long multiplication, you would get $5,847.75. However, if you look in your review guide, this is a multiple choice item. So if it's multiple choice, I can actually skip the tedious multiplication. What I can do instead is take a look at this number and round it up. My answer will be slightly off, but all the choices are so different that I'll get close to the correct answer. So I'm going to take the area, 207 square meters, and I'm going to round this money amount to roughly $30. So I'm going to multiply by 30, and the trick is I can just tack on a 0 at the end. So 3 times 7 is 21, carry the 2. 3 times 0 plus 2 is just 2, and then 2 times 3 is 6. I get $6,210. Now this is higher than what it would actually cost, because it actually costs $28.25 per square meter, but I'm multiplying by 30 to make my multiplication easier. So I'm going to look for a choice that is less, slightly less than $6,210. And if you look at your choices, your first choice is $1,808. Well, that's wrong. Second choice is $11,695. That's wrong. Third choice is $904. That is less than $6,000, but it's way, way less. Not close enough. And the fourth choice is $5,847.75. So this has to be it. without me doing long multiplication. This is not cheating. This is using the choices to help me. This is called being a smart test taker. So if it's multiple choice, sometimes you can use the choices to help you out to make your work a little bit easier.
So this is logic, which is still technically math.
Yes, it is. You're not cheating. Good luck. Okay, now we're going to talk about graphing. This is number 40 in your review package. This 40 says 3x plus 4y equals 12. It's going to say graph using the intercepts. When they say use the intercepts, that means you just can't graph any points you want. It must be the x-intercept and the y-intercept. So what I'm going to do is make an xy table, and I'm going to put in 0 for the y, and I have to solve for x, and plug in 0 for the x and solve for y. These are going to be my two order pairs, where this is going to be on the x-axis, because that's the x-intercept, and this will eventually be on the y-axis, since that's the y-intercept. But I have to find the missing value. So to simply find the missing value, you plug in 0 for y. Okay, so 4 times 0 cancels out, so I have 3x equals 12. Do my math over here. Divide both sides by 3, and I have x equals 4. You may not be able to see this well, but I'm going to write here, x equals 4. And then you do the opposite. You plug in 0 for x and solve for y. So 3 times 0 cancels. So you have 4y equals 12. Divide both sides by 4, and we have y equals 3. And then those are my two order pairs. So this is the x-intercept, and this is the y-intercept. And then you're going to have graph paper like this. In my math lab, though, you're going to have to click on the line. There will be an icon of a line with 2 points on it. Click on the line, and just click your 2 points, and the line will be drawn for you. So I'm going to graph 4, 0. Make sure you do it on the x-axis, not on the y-axis. That's a common mistake, is students get this mixed up when they graph. So 4, 0 is 1, 2, 3, 4, right here. So this is 4, 0. And then 0, 3, go on the y, positive 3, 1, 2, 3. Okay? So this is 0, 3. And then connect these 2 points. And there's your line. And that's how you do graph this equation using the intercepts. Obviously, you can graph this line in other ways and get other points that would make the same line. But when they say use the intercepts and you use other points, it will be marked wrong, even though you get the same line that I just got with this example. So use the x-intercept and the y-intercept when they say use intercept. So pay attention for that key word in your practice. That's number 40. Okay, so this is number 27. This is 2x plus y equals 6. The instructions says graph using the slope and y-intercept. So in this case, we have to graph differently. Okay, so slope and y-intercept means that the equation must be in the form y equals mx plus b. Remember that b is my y-intercept, and my m represents my slope. So your first step is to solve for y, to get y equals. So in this equation, I have to solve for y. So I'm going to subtract 2x from both sides. I have y equals, put this first, so it's negative 2x plus 6 plus 6. Okay? So this is now in slope-intercept form, the y equals mx plus b form. So the way it works is this number is the y-intercept. That is 0, 6. Make sure you graph this on the y-axis, not the x-axis. That's a common mistake. So go to the y-axis, go 1, 2, 3, 4, 5. Cheating here. This would be 6. Here we go. So this would be 0, 6. Okay? And then the slope is a negative 2. Okay? But write this as a fraction. So it's negative 2 over 1. When the slope is negative, that means I go down and then over. When the slope is positive, then you go up and then over. But in this case, it's negative 2 over 1. So I'm going to go down 2 spaces and over 1 space from this point that I just graphed. So this would take me to my second point. Okay? So just count. Go down 1, go down 2, go over 1. That's it. Stop. Make that point very clear. And you have 2 points. That's enough to make a line. Of course, in my math lab, don't forget to click on the icon that shows the line with the 2 points on it. And this is my line. Okay, so if the slope is negative, you go down and over. If the slope is positive, you go up and over. And once again, you should know what the line would look like, because if the slope is positive, the line looks like this. If the slope is negative, the line looks like this. And of course, if the slope is 0, the line looks like this. And if the slope is undefined, the line looks like this. Okay. Okay, so this is number 56. They're giving us a picture of a line that goes up and down like this, as the vertical line, and they're asking us to find slope. This question happened to be multiple choice, so A is 3 over 2, B is negative 2, C is 0, D is undefined. Remember the 4 types of slope that we talked about in the previous video. If the line looks like this, the slope will be positive. If the line goes down, the slope will be negative. If the line goes straight across a horizontal line, the slope will be 0. And the line goes up and down, the vertical line is undefined. So if you know your 4 types of line, then by just seeing this picture, you know it has to be D, undefined. Another way to remember that this line is undefined is a vertical line looks like a wall. Okay? The only one who can climb a wall is Spider-Man, and his identity is undefined.
Expect that you recognize that the slope of a vertical line is undefined. However, if you need to find the slope of any line, this one included, then we can go back to our slope formula. I'm going to choose any 2 points, any 2 coordinates that I can easily find on this line. So I can choose this one, and the coordinate here is negative 2, 2, or this one, the coordinate is negative 2, negative 3. And there's nothing special about these 2 coordinates other than I could find them quite easily. I could identify the elements of the coordinates. So our slope formula is y2 minus y1 over x2 minus x1. So I'm going to call this my first coordinate and this one my second coordinate. When I choose y2, I'm going to choose this 2 minus y1. And then, in my denominator, negative 2 minus negative 2. Notice how the formula has a minus and this 2 has a negative on it. So those are 2 separate things. Just because you write this doesn't mean that it counts for both of these. The reason why this is important is because this is going to turn into plus 2. So, right here, I get a 5 over 0. Now the reason this works is that I have 5 spaces of rise between the 2 points that I've chosen, and I have 0 spaces of run in the 2 coordinates that I've chosen. So I have a fraction with a number that's not 0 on the top and is 0 in the denominator. In other words, I see a fraction that's undefined, and that's my slope. So my slope is undefined for this vertical line.
Okay, so number 14, this is a problem about finding slope between 2 points. So whenever I give you 2 ordered pairs, the formula for slope is just y2 minus y1 over x2 minus x1. So I'm just going to randomly call the first point x1, y1, and the second point x2, y2. You can go either way. It's up to you. You want to call this x1, y1, and this x2, y2. It will not make a difference. So I'll call this x1, y1. I'll call this x2 and y2. Okay? And then once you identify which point is x1, y1, and which point is x2, y2, it's plug and chug. Okay? So when I write the formula, I keep the minus sign in the middle, because the minus sign is part of the formula. Because sometimes you might get a double negative. This minus sign is part of the formula. And then just fill in the blank. So y2 is here, 7. Okay? y1 happens to be a negative 7. Okay? My x2 is 6, and my x1 is a negative 2. So be careful with your signs. So I have a double negative, okay, so a negative and a negative becomes a positive, 7 plus, so we have equals, okay, 7 plus 7 is 14, over. A negative and a negative here is also a plus. 6 plus 2 is 8. So I have 14 over 8. This is a fraction. Make sure I can make sure to reduce. So 14 and 8 are both divisible by 2. So divide by 2, divide by 2. And I have 7 over 4. So make sure you always simplify a fraction. Okay? And 7 over 4. And that's the answer for that one. If you do it the other way, you should still get 7 over 4. What would happen is if these two ordered pairs were flipped, you would actually get negative 7 over negative 4. But we know that a negative and a negative is a positive 7 over 4, giving you the same answer.
So, there are two ways that we could look at simplifying radicals. The first one is making a good box and a bad box. So we're going to put a good box to collect all of the perfect squares, and then a bad box to collect things that are not perfect squares. Things that are perfect squares should be good, right? So, the good box, I have 75, and I need to find the biggest perfect square factor of 75. What's the biggest perfect square factor of 75, Professor Kasha?
Well, I think about 75 cents. So I'm thinking about quarters. So 25 goes into 75 3 times.
Right, so the 25 is the perfect square.
And 3 is the bad.
Exactly. So, the next thing, whoops, from my 54, this should be b squared. The next thing that I'm looking at is that a. Now, I need even exponents because I need to take half of them. So 3, I don't have a nice pretty half.
It's odd.
It's odd.
It's odd.
So it's odd. So what we're going to have to do is we're going to sort it out because a cubed is really the same thing as a squared times a to the first, right?
That's correct.
Now 2 is an even number, and I like that one. That's a good one. So a squared, and then that spare a I'm going to have to throw over here.
Okay.
Now b squared, the square is even.
So because it's even, don't break it apart. Just put it right in the good box.
It's a good box.
And you're almost done.
Almost done. Now, what we're going to do is we're going to simplify the good box because we sorted out everything that was nice and a perfect square into this good box. And anything that didn't work, we're going to throw over here. So we're going to take the square root of 25, get a 5. Now it's escaping from this box because I can take the square root of everything over here because we chose it to be so. And then a, the square root of a squared is a, the square root of b squared is b. And then this bad box, can't do anything with it. I just have to keep the square root of 3b. Now, that being said, we have,
This is 3.
oops,
That's okay, it's 3A.
3a.
And anything that's bad stays locked up forever. We don't want bad people out on the street.
Now, the next thing that we can do is we can look at the other method, which requires prime factorization. So, if I want to look at the prime factorization of this radical, 75's prime factorization is 3 times 5 times 5. And then I have 1, 2, 3 a's, and b, and b. So here's the prime factorization. Now this method has been likened to going shoe shopping from courtesy of Professor Ziegler. So we talk about going shoe shopping. If you want shoes, you take 2 of them and you put it in one box and you carry it out in one box. So what I'm looking for are pairs of things that I can take out in a single box. So I can't take out a pair of 3's because I don't have a pair of 3's. You're not going to take one shoe out of the shoe store. It's not going to work. No, unless you want to hop a lot, it's not going to work. So what we're going to do is we're going to take a pair of 5's because I can buy those shoes. So I can take those out, and then I say I have 5's. So now I'm not going to write 5 and 5. You see, 2 shoes go into one box. So I'm only going to write one of those down. The next thing is that I find a pair of A's. So I have A shoes. I have B shoes. Now anything that didn't have a pair, you're not going to take that with you. You're going to leave that in the store. So 3 didn't have a pair, so I'm going to leave that one in the store. And I have a spare A that I'm going to leave in that store.
There's the 3, just one 3, stays. There's one A, stays. You only take pairs. Okay, welcome back. It's possible that you have a word problem that involves the use of Pythagorean theorem. This problem is not in your packet, but it's possible that you might see this on the final examination. So this is an example, okay? So I'm going to go ahead and read it. A TV has a length of 20 inches and a diagonal length of 25 inches. Find the height of the TV. So obviously a TV is a rectangular shape, okay? And it says the length, which is this part, is 20 inches, Okay? The diagonal is just a fancy word for the line segment that goes from this vertex to this vertex in the middle, cutting the rectangle in half. So this is really the hypotenuse of this right triangle. So whenever they use the word diagonal, it's really the hypotenuse of the right triangle if it's a rectangle. Okay? And that's 25 inches. Okay? And they asked me to find the height of the TV, which is this part here. So the height, I'll just call it B. Okay? So this is my A, and this is my C, and this is my B. So you have two ways to solve this. You can the first way is to use Pythagorean theorem. A squared plus B squared equals C squared. So A squared plus B squared equals C squared. So A squared is 20. So I do 20 squared plus B squared equals 25 squared. 20 squared is 400 plus B squared equals 25 squared. If you do the multiplication, is 625. Take away 400 from both sides to get B squared alone. And I will have B squared equals 225. Well, I don't want B squared, I want B. So B itself is the opposite of squaring it. So the opposite of squaring is just a square root. So B itself is the square root of 225, and the square root of 225 is 15 inches. Another way to think about this problem is there are common numbers that we know in mathematics that will make a right triangle. And these are called Pythagorean triples. And a famous Pythagorean triple is 3, 4, 5. So if you know that 3, 4, and 5 is guaranteed to make a right triangle, you might have seen the pattern that 25 here is simply 5 times 5. You might see here that 20 was just simply 4 times 5. So if you notice a pattern that I have the 5 and I have the 4, what's missing? The 3. So this would just be 3 times 5, which equals 15 inches. So if you know your Pythagorean triples, and there are many more, and you see the pattern, then you can just go ahead and pick out the missing number and multiply by the common factor that the other two sides were multiplied by. Or you can use Pythagorean theorem and take the square root at the end to get 15 inches. Either way, as long as you get 15 inches, you're good to go. And you can go ahead and enjoy your new TV set.